Hello, welcome to my electronics lab again. I'm doing a video here on decoupling circuits from the power supply, and I'll explain what I mean by that, and I'll show you a little example of what I've been doing here. But here's an example right here in a booklet here from the old Radio Shack AM/FM radio kit. And I've seen these schematics like this before, where the positive terminal of a particular part of the circuit would go through a resistor before it goes back to the positive supply, and then there'd be a capacitor that bypasses. And I understood that was for decoupling signals from the supply, but I never really understood why that was so important and things like that. And but I now find out, because I'm building a circuit here that requires this, and I'll show you how this is, what I mean by this. Okay, this is the circuit that I'm working on right now. I'm experimenting and playing around with designing transistor pulse width modulation circuits. And I have the stable multivibrator here, an integrator circuit, this here RC low pass filter, a couple amplifying stages, and then a Schmitt trigger circuit. And that produces my from square wave to a triangle wave output through here, and then that gives me my pulse width modulated square wave out here to run a load. Okay, so as I'm building my circuit here, I have my astable multivibrator circuit here I built, and the integrating network here to produce a triangle wave, and the amplifiers and the Schmitt trigger circuit here. And so I'm checking the waveforms with the astable stable multivibrator circuit output, and I'm seeing a square wave out here. However, though, I'm going through the rest of the circuitry here, and I'm looking at the triangle waveform as it's coming out of the integrator, and it's going into coming out of the first amplifier. And this is my triangle waveform there. Now, as I look at that triangle waveform, I'm realizing that that's just not very good of a triangle waveform. Now, I realize it has to be the inversion of the square wave, because it's going to a harmony mirror amplifier, but it's just not getting a proper triangle wave shape. Okay, so now let's go through the process of troubleshooting this. The first thing I want to do is I want to disconnect the stable multivibrator from the rest of the circuitry. This is now operating alone, and everything else is disconnected from that particular part of the circuit. And I want to check the waveform and see if I'm getting a good square wave. Okay, it shows I'm getting good square wave. There's no distortion or anything. The roundover is typical of a transistor RC network like that. Okay, so now step 2 in this troubleshooting would be to, again, keeping the stable multivibrator separated from the rest of the circuitry as far as signal is concerned. Checking with the oscilloscope now this first amplifier here. And this amplifier is connected to the power supply. That's connected to the power supply for the multivibrator as well, and see if there's any signal coming out of here that could indicate on the power rail itself. And sure enough, that's exactly what I have. I have a square wave output here off of an amplifier that has no input signal coming into it. The only thing that's happening is this is amplifying what's going on the power rail. So what that tells me then is that this multivibrator circuit is putting signal on the power rail, and it's being picked up through the rest of the circuits, and it has to be decoupled from that. Okay, so for my decoupling network, I have a resistor and a capacitor to ground. I have the resistor going to the positive supply, and we'll look on the schematic and see what that looks like. Right here, the resistor here, RF, is going to the positive supply, and I have a bypass capacitor right here, CF, to ground. And I make the capacitive reactance 1/10 of the resistance here. I have 100 ohms here, and I got about a 47 microfarad capacitor in here, around 1/10 or so capacitive reactance with respect to the ohmage here. Now let's see what that looks like on the waveform. So I'll take this here and move this over to the low pass filter now, and let's look on the oscilloscope, and it's completely gone, and there's the waveform now off the power rail. This is the power rail that the amplifier is picking up, and we can see that the parasitics on the power rail is down to a minimal. So now we have decoupled the unstable multivibrator from the power rail. Okay, so the next step now would be put the signal coming off of the vibrator back now into the rest of the circuitry and see how everything works now on the circuit itself. So I'll put the oscilloscope here on the input, and okay, we're going to look at the input of the of this, and then we're going to look at the output of the first amplifier. So we'll go over here and we'll take a look at the input. There's our square wave, the input off the multivibrator. Now let's take a look at the output of that amplifier. There's our triangle wave. So I now have a nice symmetrical triangle wave, and that's all the result of decoupling the multivibrator from the power rail, as we showed up here. That little network right there, that little low pass filter, did the trick. Okay, with my oscilloscope probes now hooked up to the triangle wave coming into the Schmitt trigger circuit for the input, we'll look at the input triangle wave, and then we'll look at the output PWM wave on the output here. And so now we bring the input voltage, the triangle wave, up into the threshold voltage, and then there's our PWM wave being established. And then we go below the threshold voltage and go down. Let me go ahead and put just the channel 2 on, and we'll just look at the output wave only, the PWM wave. And that's working very nice. Get past some of that there. Right there. Now let's take a look at it. Yeah, okay. Okay, so that's working really nice for a pulse width modulation. And I just wanted to demonstrate here a little bit of how the get those things stayed here steady. Come on, right in there. All right, getting the what am I talking about here? The decoupling. How decoupling works for decoupling the unstable from the power supply. That's very necessary in order to have proper circuit performance, and I hope that gives a good understanding of why it's important to decouple circuits at times, because it really does help out in circuit performance. Okay, thanks for watching. Bye.